So in the previous two videos, which were the tangent ratio and the sine and cosine ratios, in those two videos, all I did is solve for side lengths. Okay, given an angle measurement, I was able to solve for a side length. What our focus is going to be here is figuring out how we can solve for the angles. How could we get the angle measurements if we knew the side lengths that go with it? All right, now before we do that, I need to talk about a particular instruction. So if you ever come across a problem that says, solve a right triangle, okay, it doesn't actually say solve for X or solve for Y or any other letter, but it actually just says solve a right triangle. What that means is that you need to find everything that you don't know. You got to find all the unknown angle measurements and side lengths. So anything that you don't know, you'll need to solve for. As a hint, in every picture that you get, you're going to be provided three pieces of information. The first will be a right angle. Second, you could get another angle measurement and a side length, or you could be getting two side lengths to go with it. But you'll be getting three pieces of information for any triangle, which means that when you solve that right triangle, you're going to need to find three other pieces of information. You get three, you got to find three. All right, but our main focus here is really going to be about how to solve for angle measurements. And the way that we're going to do that is using these three things here. You can think of them as the inverse operations to the tangent, the sine, and the cosine. They undo things. Anytime you see these with that -1, you need to be thinking that this is going to work backwards and it's going to solve for angles for you. Okay, now there's a couple different ways that you can read these. You can read this as inverse tangent. This would be inverse sine. This could also be inverse cosine. However, the way that I was taught and the way you'll probably hear me call these, this will be called the arctangent, ARC, arctangent. This would be called the arcsine. This would be called the arccosine. So sometimes you might hear me say inverse, but most often you'll probably hear me say arctangent, arcsine, arccosine. And once again, these are going to be used to solve for angle measurements. All right, so I really only have one example here, but the instructions say solve the right triangle. So what that means is that we got to solve for everything that we don't know. All right, to get things sort of going here, what I'm going to do is go ahead and label some stuff here. That way I can reference them in a little bit. Okay, so three pieces of information you get. You've got your right angle and you've got two sides that are here. So the three things that we don't know, which we're going to have to solve for, measure of angle A. Oh, we got B here. All right, so the measure of angle C, we'll have to figure out these two. And we'll have to figure out that third side that we have right there, which I can go ahead and call little c since it's across from capital C. Okay, so these are all the items. These are all the items that I got to solve for. Usually at the beginning of these problems, there might be one piece of information that you can get pretty quick. Like if I did have one of the angle measurements with the right angle, I could get the third one really quick. In this case, that's not my situation, but I do have two of the sides, and this is a right triangle, so I could do Pythagorean theorem to figure out the length of this side here, which I'm calling little c. So I'll go ahead and knock that out first. We'll take our hypotenuse, 6, square that, subtract 4 squared. That would be 36 minus 16, which is going to give us 20. All right, so to finish that, I'll need to take the square root of 20, which is going to evaluate at about 4.47. Okay, so we can take that as an answer. That'll be good. All right, at some point you're going to be taught that you don't have to take decimal answers to things. So I'm going to go ahead and demonstrate one more thing here. The square root of 20, because it isn't a perfect square, what it can do is look at the factors that it has inside of it. So the square root of 20 can be looked at as the square root of 4 times 5. And 4 is a perfect square. 4 is a perfect square, so that I can actually square root, which would be 2, move that 2 to the outside, and then just keep the 5 inside. And that is going to be equivalent to the 4.47. So let me type that in real quick. We got 2 square root 5 is exactly the same thing. So that answer would work as well. This would be a perfect answer. This will be okay right now as an approximate answer. So the big thing that we need to look at now is how to solve for angle measurements. Let's go ahead and start with angle C here. All right, now with respect to C, the 6 is the hypotenuse and the 4 is the adjacent. Okay, so that'll be a cosine problem. And I can start with this. I can write down that the cosine of C is going to be equal to 4 over 6. I can do that. All right, now the goal is to get the C by itself, which means that I got to get rid of the cosine. And you can't just divide the cosine away. Things don't quite work that way. But we have these inverse operations now. We've got the arc cosine. Okay, so if I were to take this side here and place it inside of an arc cosine, that inverse operation will actually just cancel all that out, leaving you with a C. All right, now for the other side, what I'm going to need to do is the same thing. I'll have to take that ratio and put it into the arc cosine. I have to put it in there. Okay, and that was 4 over 6. So ultimately, when you look at it though, when this cancels out and we get C by ourselves, we figure out that C is actually equal to the arc cosine of the ratio. Okay, and what I want you to notice here is that we don't flip the ratio. We don't do anything with it. It's still going to be the adjacent over the hypotenuse, but instead of putting an angle into cosine, you're going to put the ratio into the arc cosine. All right, and then for most calculators, the way that you're going to type the arc cosine, you're going to use the same button that you would use for cosine, okay? Except before that, you're either going to press second or possibly a shift button. So I'll press second. My calculator, you see a little arrow pop up. And then when I press cosine, you actually get the arc cosine. All right, and then inside of that, I'll just type in 4 divided by 6. Too many parentheses. Type in 4 divided by 6, and I get my angle, which is about 48.2 degrees. It's about 48.2 degrees. Okay, and then as far as angle A, what you could do is just switch the trig function that you're using. Okay, with respect to A, the 4 is the opposite. The 6, it's still the hypotenuse. That would be a sine. Okay, so to get angle A, what I could do is use an inverse sine of 4, 6. I can do that. Okay, different function, and this should still work out with the same numbers. Okay, so I'll press second sine. Then I got 4 divided by 6, which is going to give me 41.8. All right, and then if I add these two answers together, I should get 90 because we've already got 90 accounted for here. Okay, I'll take these two answers exactly as they are. Okay, so I don't have to worry about rounding. And we get exactly 90. Now then you have one other option that you could have used to get angle A at the end as well. Once you do have C, you could just subtract it from 90 to get the A. However, maybe doing another trig problem would be a good idea because then you can do that final test of adding your angles to see if they do add up to 180.
Later, blah.